Here is college question. One block of mass, M1, is attached to string, and we push the mass M2 by compressing string by distance A from equilibrium position. We release them. When they come back at equilibrium point, they separate. Why? Because the velocity is maximum at equilibrium position. Mass M2 continues to move at velocity v. For mass M1, the velocity decreases in newfound frequency. Floor is frictionless. Pause the video if you want to read the question carefully and solve it. We need to calculate V and D. D is the separation when the spring is fully stretched for the first time. Let us find out. Finding V is easy. When spring is compressed by distance A, the initial potential energy is half times K times A squared. Since the kinetic energy is zero at compression, its total energy is the same as the potential energy. When it moves to equilibrium position, as shown in C, the potential energy is zero and the total energy is kinetic energy, which is half m1 plus m2 v squared. Energy is conserved, so half Ka squared is converted to kinetic energy. We then find velocity. We now numerically calculate velocity and find it equal to 0.5 meter per second. This is the answer for the velocity. Now, for the next part of question. In this part of question, we need to find distance d as shown d in the figure at the bottom. D occurs when the time is time period divide by 4. When the time period over 4 has passed, the m2 moves by distance v times the time period over 4, and the m1 move to newfound amplitude, say a prime. D is the distance between the two, which is this v timed t divide, by 4 minus a prime. Now, newfound angular frequency is square root of k by m1, and not m1 plus m2. Why? Because m2 has separated. The angular frequency is also 2 pi by time period. So we can find the time period. This time period can be used in the calculation of d. We use conservation of energy for mass m1. The kinetic energy at the equilibrium is converted entirely to potential energy at time t over 4, and it is at the new amplitude a prime. And we calculate the value of a prime. We are ready to calculate the value of d. We substitute the value of a prime in the time period, and we finally calculate d as 0.0856 meters. And that is the answer. This ends the video.